Hi friends, welcome to my YouTube channel. Firstly, myself I am Nitya Shrivi, presently pursuing my education in Sri Venkateswara College of Engineering, Bangalore. Today I am here to explain how animation is useful in present world and what are the parameters of animations in physics terms. The physics of animation, from principles to practical applications. Welcome to a deep dive into the fascinating world of physics. Based on animation, we will explore how understanding the laws of motion, gravity and force can elevate animation from static drawings to believable capturing storytelling. Before going to the topic of animation, we know some concepts. We heard about laws of motion proposed by Newton. First law explains that object remains in the state of rest until an external force acts on it. And second law tells about force equals m into a, that is force equals to mass times of acceleration. And finally third law says that for every action there will be a equal and opposite reaction. Gravity also play an important role in animation, that you may get doubt that what is gravity and how it plays an important role. Gravity means the force that attracts objects towards one another. It plays an important role in animation because it helps the animators to replicate real world physics in their creations. Force also play very important role in animation. Already you are familiar with the force. Then why force is important in animation? Because it can create realistic movements and create the better experience to the viewers. Now we study about what is animation in physics terms. What is it? Physics-based animation leverages the principles of physics to create realistic and dynamic motion. Instead of manually animating every frame, the technique stimulates how objects behave in the real world. This involves calculating factors like gravity, mass, friction and momentum. Animation in physics refers to the physics-based animation, which is a computer graphics technique that uses physics principles to create realistic movements and interactions between the objects. And why does it is important in a present world? Physics-based animation enhances realism, brings lifelike movement to animated characters and objects. It allows for a wider range of dynamic motion, for subtle interactions to a large-scale explosions, making the animation more believable and engaging. For examples, in some movies, they require a lot of people in a single frame. At that time, they use concepts of animation because to create a realistic feel to the audience. Nowadays, animation is used in the fields of video gaming, movie making, marketing, etc. Now we discuss parameters of animation one by one. Firstly, the principles of timing and spacing. Timing. Timing refers to the speed and duration of an animation. As well, timed animation feels natural and creates a sense of rhythm. That is how long an action takes place. For example, we can see a ball is hitting the trampoline from a certain height. From that height, what time it takes to hit the trampoline, so that animators create an animation. The next word is spacing. Spacing is the distance between frames in an animation. It affects the smoothness and flow of movement. By adjusting spacing, animators can emphasize different aspects for the motion. For example, we take this example only. The ball starts from the initial point and reaches the final point in the same time. The distance covered by the ball, we call it as spacing. By knowing the distance, animators can create the animations easily. The next parameter is concepts of force, momentum and acceleration. Force. Force is a push or pull that can cause an object to accelerate or change a direction. Momentum. Momentum is a tendency of an object to stay in a motion. It's a product of object mass and velocity. That is, it is a measure of how much speed that the object is moving. Then acceleration. Acceleration is the rate which a object velocity changes. It's affected by the net force acting on the object. It it affects how characters and objects move and interact with their environment. Hence, we see the picture of a rocket. It works with the principles of force, momentum and acceleration. The next parameters are squash and stretch. Squash. When an object is compressed, it squashes or exaggerating its weight and mass. Squash means flattening or compressing along a certain axis. Stretch. When an object is extended, it stretches, emphasizing its elasticity and momentum. That is, it provides weight, elasticity and believability to characters and objects. Then realistic motions. The technique adds dynamism and visual impact, making the animators feel more realistic and lively. It is the key concept of animation which makes the viewers to feel realistic movements. The next parameters are axes and aces in or out for realistic motion. Arcs. Most natural motion flows curved path, known as arcs. This adds realism and smoothness to the animation. Arcs, that is, almost all objects move in curved path. There are rare objects move in a straight line. So the objects that moves in curved path are called arcs. Ace in or out. Ace in or out is a technique where movement starts slowly, accelerates, then slows down again at the end. This creates a more natural and realistic transition. That is, we can start animating video slowly and accelerate or speed up to maximum speed, and then in last we can make down it to less speed. This creates realistic feel. The next parameter is exaggerating and its role in animation. Purpose. Exaggerating amplifies motion and expressions, making animation more expressive and entertaining. It adds a cartoonish flair to the animation, makes it more engaging and memorable. Exaggeration means the act of representing something as more dramatic than is actually is it. Types. Exaggeration can be applied to various aspects of animation, including character, design, movements, timing and expression. It helps to convey emotions and emphasize specific actions. The next parameters are incorporating Newtonian mechanics. Gravity. Gravity is a fundamental force that affects all objects. Animators use it to create believable falling, bouncing and rolling motions. We already discussed so many things about gravity in first. Then we move on to the friction. Friction is a force that opposes motion between surface. It affects how objects slides, roll and stop. Then inertia. Inertia is the tendency of an object to resist change in motion. It affects how objects respond to force and impact. The next parameter is stimulating wave properties and optics. Refraction. Refraction is a bending of light as it passes through different mediums like water or glass. Reflection. Reflection is the bouncing of light off a surface. It creates shadows and lightenings and adds realism to animation. Diffraction. Diffraction is the spreading of light as it passes through an opening or around an obstacle. This phenomenon can be used to create realistic lightning effects and visual details. Thank you for watching this video.